We are going to start our third talk of the day. And again, I'm not going to do intros. I'm going to let the speakers do that. I will have the mic again. We'll shoot for 10 minutes for questions at the end. And again, the mics are just for the recording, so it doesn't actually magnify your voice, so talk loudly if you would. All right.
Okay, can everybody hear me? Good, I'll try to speak up. So my name is Greg. I'm the restoration manager at the White River Partnership. A little bit about myself. I've been doing culvert replacements using stream simulation since 2012 and dam removal since 2016. We've done a lot of them. And so we're just going to talk a little bit about some of the, at least initially, about culverts and some of the things that we've done, some of the things I've seen other folks do that work, and just kind of give you guys some ideas. So culverts. So I'm going to borrow something from someone. So we think about culverts, we think about those are ways to get our roads over streams. Another way to think about it is a way to get our streams under a road, right? And I say it like that is because we oftentimes don't really think about the stream, or the stream is sort of the afterthought. Like you're going in there and you're just replacing the culvert. The goal is to improve the transportation infrastructure. But if we get the stream right, you know, connecting upstream and downstream, material in the structure itself, and if it's sized appropriately, then everything else works, including the transportation. I like to say what's good for fish is good for people. So we're just going to talk a little bit about material and structures and connecting upstream and downstream. Big hole. This is a site up in the Wing Brook drainage. Really complicated, huge hole. Temporary road bypass, stream bypass. The stream bypass was well over 100 feet. The upstream and downstream difference in elevation was over 10 feet. So the stream coming into the inlet was 10 feet higher than the stream at the outlet. It's kind of a nightmare. But the contractor that worked on this did an amazing job of limiting sediment input during construction, providing for access for people in the community, emergency vehicles, and then connecting to the stream upstream. We had over 200 feet of channel work outside of the structure. So the structure was 60 feet. A lot of channel reconstruction, and to get that right was sort of complicated because big hole, and you still got to maintain the traffic and the stream and get the road open within a really narrow window, because it was harder than we thought. So, or you get lucky and you're replacing a culvert with a bridge and you don't really have to worry about the stream so much, and then you can throw in a temporary road. And I just want to put that in there to plug these temporary bridges. So thank you. This is a Yard King. We actually borrowed this for a project. Really great, couple waste blocks. Really simple. Just wanted to throw that in because I know it comes up like you can't always close the road, and so that's a pretty good solution. Feel free to chime in anytime. So culverts, a lot of these structures are embedded, so they have a bottom. This is a multi-plate. I believe the width here is 18 feet, a little over 18 feet. Pretty big structure. So it's embedded. You can see on this one, there's the temporary stream bypass on the left, or yeah, over there. And so how do you get material in there? A lot of people talk about like leaving some panels off the top and dropping them in with an excavator. I've never tried that. I know some have and it's worked. But you still got to manipulate that material in the structure. And so what I like to do is paint lines. So you have your stream bed elevation through your structure at your inlet and outlet. Run a string and then paint it. You see 2 lines. So we're using stream simulation. So our structures are wider than the Vermont standard. And so we're accommodating that width with a bankful bench. So we have a bankful bench, which is the second line. This one was early. This is 2013. It's about a 13-foot wide structure. Contractor has got a mini excavator, and it worked really, really well. We could call in for bigger pieces, and he would bring them in. Worked really well. What we realized after the fact, and maybe it's obvious, but we didn't think about it, is everything settles, so you have to overfill a little bit. So if you want to match a certain elevation, you got to think about that. And so we've adjusted that. So with our painted lines, we just adjust there, and so nobody has to really think about it. And then you got to provide for ventilation. Maybe obvious, but it's not. I've been in culverts trying to manipulate stuff with rock bars, and you can't breathe. This is a very Vermont fix. It's a fan from a dairy barn. It worked really well. I think we had coats on in the culvert. It was really cold, but it was great. Worked really, really well. And then there's a lot of physical labor in there. So when you're doing these projects, plan for that. I think the first one we did, I don't think the contractor realized that was what it was going to take. And so going in, and that taught us, like at the pre-bid, really talk about what's expected. And so you'll see there's shovels and there's rock bars and there's physical labor. You're manipulating this. And then sometimes you get to do a bottomless structure and you get the benefit of an excavator. I can't stress how important a thumb is when you're grabbing rocks. I know I've worked with a lot of contractors that didn't have thumbs on machines, and it's hard. So let's see if this works. I'll look at that technology. So this one is that one that had 10 feet difference in elevation. So we're basically building steps up through. I mean, it's hard. And you can see there's a lot of communication between all the people working there. We're getting the stream right. We're taking our time, even though it doesn't look like it. And then we're, and you'll see, we're creating roughness. I know Evan's going to talk about roughness in the next presentation, but it's not a smooth channel. I mean, that looks pretty rough. We're embedding that material. And you see, we're going in and we're packing stuff in. And it actually doesn't take that long, but it is a really important part of the project. And a lot of times it gets overlooked, and so I want to stress that. So once you do that, then you got to tie it in, and that's where we had 200 feet of channel work upstream, and that was challenging because, yeah, it's just challenging. But it worked out. And then when you get the water through, a lot of people pull back and say, okay, water's there, we're done. But no, you got to make sure that it doesn't go subsurface. You got to wash those fines in. This is the first structure we did in 2012. We learned a lot. And so we're chasing water with shovels. I know folks have used power washers and washed the fines in. There's a million different ways to do it, but you got to make sure it doesn't go subsurface. So fines in your mix, when you're adding material into the structure, you got to make sure that there's a lot of fines in that mix. And we could dive really deep into material, but probably won't. And then when it's all said and done, it looks like a stream. This is that one that had, this is right after it was completed, that one that had over 200 feet of channel, and it fit seamlessly in with upstream and downstream. This structure went in 2017. Just in 2023, it went through 5 Q100 events in that subwatershed, and it doesn't look any different. And this was a perennial problem for the town. The site always had road issues, and they haven't had a single issue since it's gone in. So again, what's good for fish is really good for people. So Ben, you want to talk a little bit about dams?
Yeah. I'm Ben Canonica with Canonica Landworks, based out of Chelsea, Vermont. And Greg and I have done quite a few projects together, some dam removals, some riverbank restoration projects. And I've also done a couple of culvert retrofit projects, which I haven't heard anyone talk about today, but essentially taking an existing culvert and making it so that the pool at the bottom is passable, and maybe putting baffles in as well. We've done a couple of those, so I don't really see too many of those projects anymore. I don't know if they're still happening or not. Maybe they're just replacing them.
It's a tool in the toolbox.
But we'll get started on dams. I'm just going to kind of walk through from a contractor's perspective how the whole process in my mind works. And when Greg and I were preparing for this, we were just kind of talking back and forth about how we're both looking at the same project, but we see it, differently. And we're both working towards the same goal, but he has certain objectives, on his plate that he has to meet, and I have to also fall into those objectives, but also I need to figure out the steps and how I'm going to approach it, how I'm going to figure out how to get those steps done. So it's just an interesting way of looking at it from different eyes. This was a small, complicated dam that we did in East Bethel. And it touches on many things that have already been talked about this morning, but access is always kind of the one thing you have to figure out. And you can see that the in back, there's the town road up there, so that's the elevation we came in on. And then can't really see it in the shadows, but in the corner, this was an old stone foundation that was probably, 15 to 20 feet high that used to have the mill building on it. And then there was a couple of gates on this side, and then the dam went all the way across. The water level was up to the top of the dam when we started, and then this building on this side is very structurally compromised, but was staying. Someone was actually living in it, and so that really complicated things and made the liability quite a bit higher.
And we couldn't touch the ground because of the cultural resources, so further complicated.
Yeah, the access getting in, we had to fabric and gravel everything, just getting in off the road. And then you can't really see well in this picture, but we have a couple other ones from above, but just, it's a very narrow spot in the river channel, so getting machines from, our battery's dead, but anyways, getting our machines from up on top down into the channel and then to the dam site. You think about the elevation difference from where the water is, where the sediment is when you begin a project, and then at the end of the project, usually, you've dropped it quite a bit. Depends on the site, but this one probably came down 6 or 8 feet with all the sediment. So what else? So this, we also had to cut this concrete in a few of the projects that we've done. Some part of the dam might get left for various reasons. This one had to get left because although it looks like it was tied into this building, it actually was separated from the foundation of the building, but only by a few inches, and it's all sitting on the same ledge. So we had to saw cut that first to separate it before we could do any hammering on the dam. So that's something, I hired a subcontractor to come in and do the wire cutting for me. And once that was done, then, the hammer actually went relatively quickly on that.
You can actually see up by the house, you can see some thin covered windows, but you can see the monitors. So we were monitoring for vibration.
And it turns out once we cut it, there wasn't any noticeable vibration to the structure. So it's just good to know that going forward for other projects, how much, kind of precaution you have to put into it. And along with access is always just kind of, from my standpoint, just trying to keep things somewhat orderly and tidy. A lot of the sites, like has been touched on, is very compact. You don't have a lot of space to lay things out or stockpile. You can't see here, but this was part of a mobile home park, and we had a very small area to stockpile a bunch of material. And so these were old concrete blocks that were actually in the river, part of the abutment. And so we just pulled them out and kind of made a containment area and then filled it up. And to be able to, work in confined areas like that, it's pretty handy to have, specialized equipment that you can work in areas that are, don't allow you a lot of room. But just keeping things orderly as well kind of helps me. I work alone, so I try to make as many of the steps count as possible. And so for me, just having a sense of order kind of helps me keep things going forward. And I think it also helps with a public appearance, because if people come by and see, things are always going to look like a bomb went off at some point in the project. But if it's not like that for the whole time, I think you will get maybe a little bit less criticism and people stopping by asking questions. This is a site we worked on this summer, and this just kind of gets back to getting things in somewhat of a organized fashion. We didn't have any before pictures, but basically this is a flood chute in here that was full of all that wood for like the last 20 or 30 years. So the project was to go through, sort all that wood, and then rebuild in this lower corner what we call a log revetment was the term. So being able to go through that and sort it all out, and then be able to, we actually had a big grinder come in and ground up all the residual material, but just having to kind of work through, kind of an unimaginable log jam essentially, and think about just keeping things somewhat orderly so that you can, have things in certain areas, because once we got it all sorted out, we had to actually, all the root wads and stuff had to come over to this corner to be built. So just a certain process to think through. And like Greg and I were talking about, you're always going to have a plan when you start, but on a lot of these projects, there's numerous unknowns that you'll encounter. And so being able to kind of change your plan on the go is pretty essential. And for me, it's one of the challenges I like about it, because there's a lot going on you have to think about. But this got away from our dam removals a little bit, but just kind of showing you overall site organization. And Colby was talking about root wads earlier, and just sometimes it's a challenge finding them and sourcing certain materials for some of these projects. This was a project we did this summer, and we were able to just work in the Green Mountain Forest. We were able to go in and harvest some of their red pine, and it's honestly some of the best use of red pine that we've found, and we just buried it all right in the ground. And someday maybe it'll be uncovered as the river moves around. But some of the dam projects will have remediation, restoration aspects where we will incorporate wood. But some of them that we've done are on bedrock. So there's not a whole lot of channel rebuilding that you have to do. It really varies quite a bit from site to site how much restoration work there will be. And to me, the challenging part is usually getting the dam out of the way, but then the fun part is the creative aspect, is like rebuilding things. And some of the sites have it and some of them don't. So that's always something to kind of think about, as you're going through the plans. Is it just removing the sediment, just removing the dam, or is there then rebuilding to do afterwards? And mats were talked about earlier, and I've become a big fan of mats. A lot of my projects, I just bring mats with me, and we're not required to use them on a lot of the projects. Some of them you are. I just feel like the work that we're doing is, essentially we're trying to limit any sediment transport in the water, trying to keep things somewhat clean. And by doing little things like this, just setting up a temporary access across it, it just buys you a lot of good grace, I feel like. And essentially you're doing the right thing. You could go back and forth through the water all day long with every machine, but honestly, it's a lot harder on the machines too, going down and across if things aren't always smooth. And it doesn't really take much extra time to set up the mats and use them from site to site. And more mats. This was another root wad site that I did a couple of years ago, and this is a good example of, earlier they were talking about from when they start the design aspects of projects, years can go by until when it's actually implemented. And this project came to be after Tropical Storm Irene. There was a hotel that sat on the far side over here. And so this was 11 years, I think, in the works before we actually implemented it. And I started this last summer, and right before we were set to begin, we had the flood last summer, and the whole site got changed quite a bit. And so we delayed the start a little bit, but we had to make some adjustments. And it just kind of goes to show you whatever's on the plan from when they started doing the initial assessment can change quite a bit when you actually get to implementation.
So just to add, so the picture that said dams, and that was been working on the dam there, that was the Lower Eaton Dam. You talk about timelines. I think the initial conversation to remove that dam with the landowner started in 2002, and the dam came out in 2019. So you just think about the scale at the time. And then the other thing I want to point out this is there's a lot going on in this picture, but the first thing that I noticed was how clean the water is. And that's pretty impressive because there's a lot going on. So we noticed these things.
And just, kind of other uses for the mats. And this is essentially, I couldn't reach all the way across and do the excavation I needed to. So just by putting the mats across as, kind of a work platform and keeping the channel going through there, it just kept things, very clean. We're not required to work in the dry all the time. So I try to do whatever I can to limit, any sediment transport, just because I feel like in Vermont, they're very, I don't know, how would you? Well, I wasn't going to say sensitive. I was going to say common sense approach to working in the wet. If you go into New Hampshire, a lot of the projects you have to work completely in the dry, which requires a ton more work, just setting up cofferdams and everything. So, little things that you can do to try to keep the water clean while you're working, I feel like just goes a long way.
What I like about this is how lo-fi it is, right? And it's very effective, but it's lo-fi. I love it.
And essentially there was a gravel bar that was created on this side from the flooding last summer. And before we got started on our project, I think V-Trans had a contractor come in, and they had actually cleaned off this bar and had come in and excavated some material. So it was already kind of set up well for what we were going to do. Originally, before the flood of last summer, I was going to have to put a ford in downstream and get up onto this bank and go out across, just because the channel was very different then. So it was kind of a major impact to the plan I had, but it actually worked out much easier to be able to utilize what was there at the time of the project. More mats. This was a project where this was downstream from the last root wad project there, but essentially the engineer had come up with a plan to put trucks down across the steep bank, drive across the river, and then out through the floodplain. We had to excavate it and truck off probably 2,000 yards of material. But the bank getting down from the state road was very steep, And so we went back and forth for a couple of years while this whole project was getting ready to happen as far as how we were going to approach it. And I visited the site numerous times just trying to wrap my head around how we were going to get trucks down there. And one of the neighbors stopped by one day and said that they had log trucks that had gone down this access and across the river back in the day when they logged. And I said, well, how did you get back out of there? And he said, well, we had a skidder and we just pushed them back up the road, which that's how things get done. But thinking about having to do that with a dump truck is not a feasible application. So we came up with kind of an alternative and just brought everything across to the roadside and stockpiled it along the roadside and then loaded it into trucks. And it was an extra step on my part, but it kept the trucks out of the river, and it also was a lot easier of an access to make something like an off-road truck work than an on-road truck.
We've used those off-road trucks on dam removals quite a bit. Like at Eaton, we had multiples going. So they're very effective working in tight spaces.
And there's all sorts of temporary access options. This actually has steel under it. So this is one we set up on a private property where we were doing a stone bridge. But just getting in other places with a temporary steel and then putting mats across it. Lots of access options for that. And this was one of the first dam removal we did in Randolph. And we were just going through some of the pictures and just kind of thinking back, just to the steps that we had to take on this, and basically just using, releasing this corner and drawing down the water and then taking out some sediment. And those are just kind of some of the steps you have to think through as you're coming up with a plan to, to do the dam removals. Is you can't just, punch a hole in it and let all the water, all the sediment out all at once. So you have to kind of think through the steps of how are you going to get a hole started, to lower the water and then lower some sediment and then lower the dam some more. And every dam, has different construction to it, and some of them are already breached, so that's not as much of an issue. But some of them you have to think about how, they have different gates on them, different elevations. So how are you going to use those holes that are already in the dam to help you with your water management? And this one was just sheet piling down to ledge, I believe.
Yeah, and the thing that I was going to add here is, and we've had this happen at a couple of dam removals, where once you start removing the sediment and lowering the dam, everything kind of mobilizes upstream, and what you find can be a surprise. This one was a sewer main that no one knew was there. And on another dam removal, there were actually water pipes for someone's house that were now this high out of the ground. So, so things come up that you don't know about. So, yeah.
And I think we found another structure at this one.
Yeah.
A wood structure.
Yeah, we found, and a car. Yeah.
So that kind of gets back to just being flexible and, having good communication with your engineer, with your project manager, and being able to talk through some of these things, because as much as you can have everything on paper and have a plan, I don't think we've worked on one that hasn't.
This one had so there was some blasted rock just behind the sheet pile, some massive rock with the holes in it, with wires still coming out of the holes, and made everybody pause. Yeah, engineer got on the phone and was trying to, do we have dynamite here? Is this gonna, and you couldn't see in the hole because it's full of sediment, and you're like, what's going on? So we ended up just pulling the wire to see if it was connected to something. And there was nothing there, so.
Surprise.
Yeah, it was good.
And a couple of the dam removals we've done, we've actually ended up having to pour concrete, which was not on the original plan. And both times it was on the far side of the river from our access point. So one, we were close enough where we were able to use a pump truck and pump it, but that was not on the original plan, pouring concrete at all. It was to shore up the rickety building that we saw there earlier on. Yeah, and the other one was we were leaving part of one of the side pieces of the earlier Eaton Dam, and we had to fill in. It was where the penstock pipe was, and we had to fill that in. But that was too far to use a pump truck, and they would not. The concrete company would not bring their trucks down into the channel, so that went bucket by bucket in the excavator. And I can't remember. And I think we had a couple of trucks at least, but
Yeah, it's slow.
it's slow, yeah.
So, how do you resolve these situations with work stop and a new contract? Do you charge more money or the losses yourself?
Yeah, it's
It was not in the engineering design.
Yeah, so in those cases, it was sort of like, kind of, I think at that point, almost back of the napkin, like, how are we going to solve this problem? Who do we need to talk to? And then, do we have the money? And, and you're in the river, you're taking out a structure, you can't really stop. And so you got to make a lot of those decisions kind of on the fly and talk to the right people, the regulators, the cultural resources, and, check the budget. Yeah, so.
So the financial risk ends up on your hands, on your
Oh,
lap?
yeah, oh, yeah.
Okay.
Yeah, it's stressful.
Even when the engineering firm did not. do
Yeah,
the
so,
work?
yeah, I mean, the engineer's involved, but, we have the budget, right? And yeah, so it can be stressful.
And not to say that he had overlooked these items. I mean, originally he had called for putting in some cinder blocks and trying to get that in a round hole. But once we got into it and kind of got things exposed, we just realized that probably wasn't going to be the best way to go, just for strength and longevity. So we ended up filling it with concrete on both applications.
Yeah, and the one where the house, and you'll see a picture of it, and you'll see it, so where the dam, the face of the dam that we were leaving that we cut, extended in front of the old mill building that's still a residence. And when we exposed everything, there had been a gate that we kind of knew about, but that we were just going to kind of block off the gate. But when we opened it up, everything was rotten, like all the concrete. And it was this massive hole that we just couldn't leave under this woman's residence. And so we had to come up with a plan to basically form a wall to block it. So, yeah, being nimble on his part and everybody involved's part. Yeah.
When you found the wood structure behind this dam, how much did that slow the project down?
How much did what?
How much did that slow the project down?
It didn't really slow it down much. No, it wasn't.
Just a housekeeping note, if you have a question, let me
Yeah.
bring you the mic. It's not to amplify your voice, but it is for the recording. So
Yeah.
raise your hand and I will come to you with the mic.
The cultural resource part can slow stuff down quite a bit. Usually on the front end, but there is that caveat. So when you're doing the project, if you find something that has not been documented, you have to stop and you have to notify the proper folks. We had a project where we found something that we were like, wait a second, what is that? We just saw it. And we're like, well, we're just not going to go there. So we didn't disturb it. We're not going to disturb it, so we don't have to stop and notify. We saw it. Okay, we're just not going to touch it. So.
And getting back to working in the dry versus the wet and just kind of coming up with, alternative ideas for what was on the plan. This was the root wall project from the summer that the plans called for having, basically having a line of the big sandbags all the way from up here. We'd rebuild that or install that new riprap and then replace all this. And so it was going to be a very long section of sandbags. And so just thinking about having to install those, maintain them, but then, then do the work behind them with the channel right there. We were able to get permission to use a flood chute that was right up there. So basically this is a big gravel bar on the inside of the bend, and I was able to get permission to excavate out the flood chute that cut through the bar and use the excavated material to create essentially a cofferdam and just divert the flow. And so just being able to kind of look at the sites, look at options like that, and again, it gets back to making sure that you're notifying the engineer, the project managers with enough advance warning so that then they could get it approved by the permitters, even though it wasn't the original plan. And this is the site with the stable building from above. And we're just getting started thinking about how we're going to fix our hole, which is behind the plywood there. And I can't see if we have done I don't know if we've done our cut yet or not.
We
but
haven't.
You can see, just how confined this is, and also, just the height elevation, getting up and down the bank, essentially just having to set material down and keep our water running through the site. And this over on this side is where the old stone foundation with the gates was, so we were able to utilize some of those gates to just kind of keep lowering the water slowly. And we did actually have to set up a little mini cofferdam here because the guys who came and did the saw cutting had to get down in there and drill through the bottom, which was 8 feet from the top of the concrete down, right on top of the ledge. They had to drill through so they could get their wire through and then cut up through with their wire saw. So this kind of had a combination of working in the wet and the dry.
And this one, you've got a lot of cofferdams going on. You got areas that are isolated, so you don't have flow going right through them. And so the water is sort of turbid because, again, we're lowering the level here, and so we're pulling material from upstream. You're going to have some turbidity, but we're trying to keep that at a minimum. And Ben did a great job of keeping having the machinery not sitting in the water, and then isolating those areas where we needed to work. It was really thoughtful. This was a really, really hard site. Not much room, and the room that we had, we weren't allowed to go on. So.
And just thinking about planning for water when you're on these sites, and at the different phases, we definitely had some high water come through while we had the site opened up. But also just think about where you are in the watershed, what size water you're working on. I've got probably one project over in New Hampshire a couple summers ago, which was the Almanusic River, and it was the drainage coming off of Mount Washington. And I got an education in working downstream on a large watershed, and it definitely makes you think about things a little differently and how it can affect your work site if you're right at water level and it takes days for that whole watershed to drain out. So it's just always has reminded me now when getting started on a project where you are in the watershed and what is the potential for situations to arise.
Yeah, I was going to say a lot of the streams in our watershed are real flashy, and it goes true with culvert replacement. So you're doing a culvert replacement, how flashy is that stream? And with the way things have been, we get rain, yeah, I think. Okay.
You got a couple more? Deep in thought here. And so you can see what we were up against as far as the concrete that was holding that building up. And if you went, the wood structure started up here, and if you went in under there, all these timbers that were supporting it were marginal at best. And so it was just very, added another layer of just awareness as we were working and trying to be very gentle, and we had attempted to try to get her to be out of the building while we were working, but she was not open to that. So, yeah, it just adds different layers of stresses to, working conditions.
Thing I'll add to this is, so you, again, the mats and the cofferdam here that he lined so we can pour through. What was really nice is at this site, water came around and you don't see it, but he put blast mats down below. And hopefully I'm not giving away too many secrets here. And so when he's hammering on the dam, he actually hammered from the mats. So the stream, the river is going underneath his excavator while he's hammering. And then the blast mat down here caught the concrete, and so it didn't go very far, and it didn't go downstream into the channel. So he was able to keep the site that looked like a bomb went off really clean. It was really nice. Huge fan of the mats.
And clean is a relative term.
Yeah. And I will throw this out. This is not the norm, and there was a lot of legal work that went in to protect all of us in case something happened. So this is not the norm. I hope not.
Okay, I hope you guys are set. Did you have a couple more, or are you good?
We're good.
Okay, so we have a little time for questions. Does anybody, well, actually, let's give a round of applause first. Thanks for a great presentation. Does anybody have a question? And I will bring you the mic.
Thank you, guys. I had a question related to when you're building the structure, your pilot channel inside your structure.
Yep.
How much the reference reach comes into play? Is it just a thing that happens in the paper and kind of doesn't translate into reality? And how much the contractor is aware of the reference reach? Do you ever visit the reference reach before you build the thing? Yeah, I want to know what the reference reach and if there's a moment that the reference reach kind of dissolves into nothing.
So Jesus is talking about reference reach. So in stream simulation, you're finding the reference reach. So go stream sim 101 here. So you're going from a stable grade control downstream of your structure to a stable grade control upstream of your structure. You snap a line, and that's your slope. And so you're trying to find a reference reach that matches that, the width and the slope and everything. And then what we do is we do pebble counts, we determine our particle size, and then we upsize for immobility on our key pieces. That's a good idea to get the contractor to look at the reference reach, and I've never done that. It's a really good idea. What we do is I'm on site. I've looked at it on all our projects. I'm on site from the day it starts to the time it ends. Stuff always comes up. I've got a lot of experience working in streams, and I want to be there. And so when we're building the structure, putting material into the structure, I know what I want in my mind, and I'm there, and I'm actually with the rock bar, and I'm helping achieve the vision that I have in my mind. But that's a good idea about getting the contractor to look at the reference reach. Say, this is what we're trying to replicate.
Right, this is somewhat like
That's a good idea.
Can I just follow on to that? Can you talk about Eastone a little bit?
Eastone, yes. I knew it was going to come up. So Eastone is it's the Vermont, be like the stone size for when you're putting. I guess you could use it for other things, but with culverts, the type of stone to put in, and it's based on the hydraulics, I believe, and the embedment, how much it needs to be embedded, and when you get your design, there's going to have there'll be a call out, or should be a call out on the breakdown of your material, and the Eastone will be in there, and it'll be like E2 or E4 or whatever, and it'll give you, if you look at what that dimension is and how much it needs to be embedded. We're using in StreamSim, we're basing off on the particle size in the stream, and then we upsize it and we run it through the hydraulics modeling to make sure everything is stable. And then the material that we're using generally comes out of the hole, right? Because that's what's at the site, and Mother Nature knows best. But we want to make sure that those key pieces are key. And so a lot of times you may have to bring in material to make that work. Like says, I only have one project where we didn't have native material on site. We removed the structure and it was all sand. It was like bedding. And the contractor's like, what do we do? I'm like, I guess we're gonna, get the recipe out. We're gonna make some material. And so we did, which we didn't plan on, because usually you have the material. And so that changed the cost a little bit. But yeah. Yes.
Just a question about working as the contractor and the project manager. Like, any tips for making that a really great relationship? It seems like you guys have a great relationship, but like, especially I think from the contractor's point of view, are there things you want us doing or not doing? How much hand holding? It seems like you guys have a great relationship, so I would love to steal that relationship.
Going together for a while.
We've worked together for a long time, but I work with a lot of other people. For me, it's about, I know my role, and I kind of stay in my lane. Contractors know what they're doing. They may not have the expertise in the stream, but that's something that can be taught. It's all based on, I think, on respect and listening to each other. We're working with a contractor, they're seeing things that I don't see, and they have experiences that I don't have. And I think it's good to build that trust early, and it starts at the pre-bid. And like with the culvert stuff at the pre-bid, I'm like, I'm gonna be there, I'm gonna help you get that material in the structure. You're not on your own, but just so you know, I am gonna be there. And so you can adjust your bid as, that may be a liability, I don't know, but I am gonna be there. And so you set that expectation, and then it's all about communication. Just communicate. I see Colby nodding his head. Just communicate.
I have one more question. You talked about some specialized equipment. You talked about the mats and the track trucks. Is there anything else that you would recommend or that you've found is like super crucial to the work that you're doing?
Yes. You can see it all in the pictures pretty much, but I've gotten into using some advanced attachments, and I run a grade system, pretty basic stuff, but for me working alone, all those little things save tons of labor. And it's not for everybody. Some people have a hard time wrapping their head around the cost of it, but I will keep running stuff like this. Once you get a taste of it, you'll understand what it can do. But it can also, it doesn't just make it easier for me. I feel like it can honestly provide a better product for your client. And it makes it an easier discussion if the project manager or the engineer wants me to change something, because using the attachments I use, you can really manipulate stuff very easily. So it's not a big ask if they need me to tweak something a little bit. And what we're talking about, like tweaking stuff in the channel rebuilding, like in the fish passage work, a lot of it has to be pretty exact, so there's enough water for the for the fish and the other animals to get through. So you're talking about moving stones a few inches, and you get these stones in place, and a lot of times to undo them and then rework it, it can be kind of a pain in the neck. And I'm not saying it's not a pain in the neck if you're using certain attachments, but it's a lot easier. So then it opens up the conversation better between the different parties to not feel like you're asking for another day's worth of work.
I'll just throw in, so if you're using wood, a lot of times in the dam removals, there may be a habitat requirement, and so you have to use wood. I'm gonna throw this out there. we've used, so on machines that don't have the fancy attachments, drop your bucket and hook up some lifting tongs. And then you can just grab the tree by the bowl and lift it up. And if you have a thumb, you can steady it with your thumb. And then you can swing it around like a big baseball bat. It's pretty cool. Really easy, lo-fi, and it works really well. We've done it with trees that are 60 feet long, you know, the bowl length with a root wad and 18-inch at breast height, and we're just picking them up like they're nothing. And then you can manipulate them real easy. I'll throw a plug. Ben's equipment is very specialized, but I will say that it changes in a stream, or you're working from going in like 2-dimension to 3-dimension. Like the ability to do things it's mind blowing. And the first time we used that was on a dam removal, and I was blown away. Incredible. Yeah.
So I've heard you mention, is this on? I've heard you mention the thumb a few times. Obviously a good tool. I love the snorkel kit on the hammer to get a little deeper in the water when I need to. But could you list a few of your other favorites and why they're your favorites? Like for which part of it it's your favorite on the attachments?
Yeah.
Keep it short, actually, because we are a little bit past time, so 10 minutes.
So, in a nutshell, the tilt rotator system that I use is it's all hoseless. So you'll notice a lot of pictures. I just have one machine down the river. You hook up the hammer, no hoses. Grab the bucket, no hoses. It takes seconds to change from attachment to attachment. Grapples, I have numerous grapples for different applications, whether setting wood, pulling rebar, pulling pins. It's kind of endless, and now if you do any shopping, there are so many attachments out there, you can spend a lot of money very easily.
And that's why I was kind of wanting to hear what your favorites were because of that.
Yeah, they all have their place, really, I mean, depending on what you're doing.
This isn't about equipment, but I have to make this plug. I have to say this. Sorry. Spill kits. I didn't talk about it. Spill kits. We require them on all our projects. If the project doesn't require it, doesn't matter. Have a spill kit on site. Have one in your machine. Stuff happens. Even with the best intentions, stuff happens. Let's protect our resource. So spill kits.
Bill Kids.
Spill kits.
All right.